Now, the last topic before the test is systems of nonlinear equations. And basically, it's done similarly to linear equations with a few little extra twists involved. So here we have a system of equations: y equals x squared minus 4x plus 4, and y equals 1 half x plus 2. It's nice to know what the picture of this looks like, but it is not necessary when solving the system algebraically. So here's a picture of it. So you can see the line, of course, is the y equals 1 half x plus 2. Then the other curve, the blue one, must be x squared minus 4x plus 4. And I've also labeled in here the 2 points of intersection. So these become our solutions when we can solve them to this system of nonlinear equations. So you can have multiple answers in this case. With linear equations, two lines only intersect at one point. If you have nonlinear equations, there's no end of how many points we can actually generate. So to solve this one, we're going to go back and do substitution. Uh, Generally, if it wasn't solved for one of the variables, I would, and I'm going to substitute into the other one. Now, sometimes there's different types of substitutions where you don't want to solve completely for a variable because it already shows up unsolved for in the other equation. So we'll see that when we get into it. But for now, let's do a little substitution. So the easiest substitution, obviously, is going to be this is already solved for y. So I'm going to substitute that in for this y up here. So my equation, when I set them equal to each other, I'm going to get this. And then from here on out, all it is solving for x, the way we've been doing it since the beginning of the semester. So first off, I don't like fractions, so I'm going to multiply both sides of this equation by 2. That way I don't have to worry about fractions. It might make the numbers a bit bigger, but larger numbers and dealing with fractions are two different things. All right, so after I multiply by 2, I'm going to get x plus 4 equals 2x squared minus 8x plus 8. And then since there's a square involved, I'm going to shift everything towards the square and get it equal to 0. So I'm going to subtract x and subtract 4. And come up with this equation. Now, sometimes these are factorable. Sometimes you might want to be able to complete the square. But if all else fails, quadratic formula still comes in kind of handy, especially if the roots are imaginary. All right, so I'm going to try to factor this. 2 times 4 is 8. I'm going to do this by the x method. And I want to come up with factors of 8 that add up to, remember factoring, the negative 9, which would be 8 and 1. And to add up to negative 9, they both have to be negative. Now, the one step that everybody always forgets is you have to divide by that lead coefficient. So these two numbers are going to get divided by 2. So the first one reduces to negative 4. The other one stays as negative 1 half. So my factors, when I shift the, first off, x minus 4. And then when I shift that 2 up front, it's going to be 2x minus 1. And you can double check this. You get a negative 8 multiplying the middle ones, and you get a negative 1, the outside ones. That's a grand total of negative 9. And another check you might want to do is x times 2x being 2x squared. All right, so my solution set is going to be setting both of those equal to 0. And we'll get x is equal to 4 and x is equal to 1 half. So this b must be at 1 half and this a must be at 4. All right, so that leaves finding the y coordinates so I can write my solution set to this system of equations. So I'm going to use the easier equation, which is the second one, and I'll substitute into that one. So y equals 1 half x plus 2. And then I'm going to substitute in 4 first. So y is equal to 1/2 times 4 plus 2. And then y here equals 2 plus 2, which is 4. So one of my coordinates is going to be 4, 4. I'll write it as a set of solution points. So 4, 4 is the first one. Then plug in 1/2. So I get y equals 1/2 times 1/2 plus 2, which is a fourth plus 2. And 2 I can write as 8/4 to get that common denominator. So y here equals 9/4. So my other point is x equals 1/2, y equals 9/4. And those are my solution set to this system of equations. This being point A, this one being point B. Not too bad, right? All right, so here's another example of a system, and I wanted to talk about the possible ways of solving it, because technically there's about 3 different ways of solving this equation. 2 ways by substitution, one of them causes a huge headache, and then elimination. So let's talk about substitution first. And then I'll just erase some of this so we can do it a different way. Substitution. And the only reason I want to talk about this is I've seen people choose the wrong thing to substitute and then cause themselves to have this horrible algebraic mess. So here's the mistake. Taking this equation and solving it for y. So if you solve this one for y, and I want to show you why it's a mistake, and then I'll erase it, so don't write this in your notes. If we solve it for y, x squared minus 2y is equal to 4, we would shift the x squared to the other side, and we would divide everybody by a -2. And this would be, it looks nice to have this y equals 1/2 x squared minus 2. It's something that we dealt with earlier. The problem is, if we take this and substitute it into the other equation, remember that's the important part, it has to go in the other equation, then what we're going to end up with is 2x squared minus 4 something squared equals 1. And inside that something has to go the 1/2 x squared minus 2. And the problem is right here. You would have to take a squared term, that x squared, 1/2 x squared minus 2, and square it. So the degree of that polynomial you would end up with is a degree 4. And you really do not want to end up with a degree 4 polynomial. It's a huge headache. All right, so let me erase the mistake. Don't do it that way. And if you end up, when you put a square inside of a square, just stop and try a different variable to solve for, or try a different method. Oops, I didn't want to get rid of the word substitution because I wanted to show you the other one, but I'm not going to solve it the other way. All right, so let's look at the other possibility. So instead of taking that second equation and solving for y, what if we solve for not necessarily x, but x squared? And this is that thing I was talking about. Sometimes you don't want to solve all the way down to a variable, because if I solve for x squared, the other equation already has an x squared. So I can just substitute into that location, not into the x. All right, so I'm going to take x squared minus 2y is equal to 4, and just get x squared by itself. And we get x squared equals 2y plus 4. And then if we substitute that into the other equation, it's going to be 2 times something. Not squared, just 2 times something, because I'm substituting in 4x squared. And then minus 4y squared is equal to 1. And what I'm substituting in is just 2y plus 4, which is fine. Now we have a quadratic in terms of y. So again, I'm not going to solve from this position. I highly suggest if you do it this way, what you'll end up with is the quadratic formula, and you'd get two answers, and then you have to take those two answers and plug them back in to the original. All right, so I'm not going to do it that way either. Sorry to say. It doesn't look horrible, but I wanted to show you another possibility. We could also, if I can get rid of this blue here, take this system of equations and do it by elimination. Or addition, depending on how you want to think about it. All right, so if we're going to do it by elimination, the only thing I can eliminate are the x squares. So that's what I'm going to focus on. So I'm going to take, let's call this one equation A, and then the other one equation B. And I'm going to take A, and I'm going to subtract 2B. That'll give me a 2x squared, and it'll be negative. All right, so this gives me 2x squared minus 4y squared is equal to 1. And then if I multiply the second equation by negative 2, I'll get negative 2x squared minus 4, plus 4y is equal to negative 8. And then I'm going to take these two and add them together. Double check my work, negative 2 times him, negative 2 times him, negative 2 times him. Yep, all right. So if I add these together, the x squares are going to cancel. We're going to be left with negative 4y squared plus 4y is equal to negative 7. Now, technically, the substitution that I did last time and this equation, I think, turn out to be exactly the same. You can double check me if you want. All right, so this is a quadratic in terms of y, so I need to get, number one, y squared positive, and number two, get it equal to 0. So I'm going to multiply through by a negative 1, so I'll get 4y squared minus 4y is equal to 7. And then I'm going to move the 7 across, so I get 4y squared minus 4y minus 7 is equal to 0. And I'm quite sure there are no factors of 28 that subtract to 4, so this is not factorable. Completing the square is not one of the nice options. So that leaves good old quadratic formula. So y is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice I have it as y equals and not x equals, so it matches the variables of my equation. All right, so y is going to equal negative something plus or minus the square root of something squared minus 4 times a times c, all divided by 2a. Now remember, the discriminant is the most important part, and that's the stuff inside the square root. This would be your discriminant here. So if I found that first, it usually makes my life a little bit easier. I'll leave it on blue. So b in this case is negative 4, so I'll put a negative 4 here, negative 4 there. A is 7, b is negative 7. I'm sorry, a is 4 and b is negative 7. And then a is 4 again. So let me bring this up. We're going to get 4 plus or minus the square root of 4 squared, 16 plus 16 times 7. 128. So this becomes the square root of 128. Don't need it to be that long. All over 8. Ooh. Now, square root of 128. Let's factor tree it. 2 and 64, 2 and 32, 2 and 16, 2 and 4, 2 and 2. I'm sorry, 2 and 8, 2 and 4, 4, 2 and 2. So I can pull out 1, 2, 2 2s, 3 2s, and leave behind a 2. So that's 4 plus or minus 8 square root of 2 divided by 8. Simplify it a little further, divide all of them by 4, and you get 1 plus or minus 2 square roots of 2 all over 2. So those are my two solutions for y. So if I have two solutions for y, that means I'm going to have two solutions for x. Let's find out what happens. So out of the two equations to solve or plug this into, the easier one seems to be the lower degree one, the second one. All right, let's see what happens. So x squared minus 2 times y is equal to 4. This is not going to be pretty. So in here goes 1 plus, I'll leave it as 1 plus or minus 2 square roots of 2 over 2. We really should just do one of them. Yeah, let's just do plus. Then minus will be really similar. So plus. All right, so this gives us x squared minus 2. Whoa, wait a minute. The 2's are going to cancel. That's nice. So get rid of that 2. We're going to just distribute a negative then. So it would be minus 1 minus 2 square roots of 2 is equal to 4. And then x squared is going to equal, add 1, that becomes 5. Add 2 square roots of 2, and we get 5. Now remember, it was plus or minus, but we'll just leave it as plus 2 square roots of 2. And finally, we're going to have to square root both sides. So we're going to get x is equal to plus or minus the square root of 5 plus 2 square roots of 2. And by the way, if we put the minus in there, it would change to a plus here. It would change to a minus there. And my other answer would be plus or minus the square root of 5 minus 2 square roots of 2. So this thing has some horrible answers. Technically, you're thinking, oh, I only have two answers because, y only has two answers and x only has two answers. But technically, x has 4 solutions, which is kind of crazy. So the solution set to the system of equations will have an x value of positive square root of 5 plus 2 square roots of 2, comma. And this positive solution came from y equaling, this is a coordinate, 1 plus 2 square roots of 2 over 2. And then we also get the square root of, negative square root of 5 plus 2 square roots of 2, comma, with the y value that gave us this, comma, and then we're going to get positive square root of 5 minus 2 square roots of 2, comma, the y value that gave it to us, and then negative square roots of 5 minus 2 square roots of 2, comma, the y value that gave it to us. Whew, that's horrible. But that would be the solution set to this system of equations. There was no nice way about this one. All right, this is a similar system. Now the first graph you should recognize, that's a circle. Has a center of 1, 2, and a radius of 4. The other graph is what's known as a parabola. Let's see what happens when we solve this system of equations. Now this one I'm going to do with substitution. Just so you get another view of it, and it actually becomes the preferred way to do a lot of systems of equations. So we could do this one with elimination because the x minus 1's match, but if one of them was x minus 1 and the other one was x plus 1, substitution is the only way to solve this system of equations. All right, so I'm going to solve the second equation for that x minus 1 all squared because it's the same as the one right above it. So let's start getting it by itself. I'm going to move the y to the other side. And then I'm going to multiply both sides by 4 to get rid of that 1/4. Okay. So take this, and I'm going to substitute it into the top equation, literally in place of x minus 1 all squared. So I'm going to get, I'm replacing x minus 1 all squared with something, plus y minus 2 all squared is equal to 16. And inside the parentheses is going to go 4y plus 8, because that's what x minus 1 all squared is equal to. All right, and then we're going to solve for y. Now, we have 4y plus 8. The parentheses, we can drop them. Y minus 2 all squared, and then it's equal to 16. So we're probably going to have to expand y minus 2 all squared. I try not expanding unless it's the last option available. So let's see here. This turns into 4y plus 8 plus y squared minus 4y plus 4. This has to be foiled. Don't just square the first term and square the second term. Perfect squares, you want to write them twice and distribute. And this is going to equal 16. All right, collect like terms and see what happens. So y squared will be by itself. The 4 y's are going to cancel. They're both on the same side. One's plus, one's minus. And we got 8 plus 4, which is 12, is equal to 16. And therefore, this is a perfect square equation. Subtract 12. And y is going to equal plus or minus 2. So that gives me two values of y that I can plug into an equation and generate two more answers. Again, the easier one, I think, is the bottom one. So I'm going to first let y equal positive 2. So I'm going to get 1/4 x minus 1 all squared minus 2 is equal to 2. So when I start solving this, I'm going to add 2 first. You could multiply by 4 also. So if I add 2 across, we get 4. Multiply both sides by 4, get 16. Hey, these are nice numbers. Not like that last example. Square root both sides. So if I square root this side and I square root that side, I'm going to get x minus 1. And don't forget to add in plus or minus. In this case, square root of 16 is 4. So that means x is equal to 1 plus or minus 4, which generates two answers, 1 plus 4 and 1 minus 4. So when y is equal to 2, I get x equal to two different numbers. So that'll generate two different points. All right, so then we're going to let y equal negative 2. Let's see what happens. So we get 1/4 x minus 1 all squared minus a negative 2 is equal to 2. The 2's are going to cancel when I subtract the 2 over, and I get 1/4 x minus 1 all squared is equal to 0. And multiply both sides by 4. I get x minus 1 all squared is equal to 0. Square root both sides, I get x minus 1 is equal to plus or minus 0 is just 0, because 0 is neither positive nor negative, so it's just 0. And I get x equals 1. So when y is equal to negative 2, I get x is equal to positive 1. All right, so let's list out all my possible solutions. So when y is equal to 2, I get x is equal to 5. When y is equal to 2, I get x is equal to negative 3. That's from this one here. And y is equal to 2, so I'm just putting those two together. And then this last one, I have x is equal to 1 when y is equal to negative 2. So the last one is x equals 1, y equals negative 2. This one only has 3 points in common, and they actually all turn out to be really, really nice. All right, so here's my last example of a system of nonlinear equations. And I'm going to do this one with elimination. I could do it with substitution, it would be perfectly fine, but I'm choosing elimination because I have an x squared in the first equation, an x squared in the second equation, and a y squared and a y squared. So elimination just seems to be the prudent way of doing this. All right, so if we call the first equation A and the second equation B, I'm going to take care of the x squares first. So I'm going to take the first equation and then I'm going to subtract 9 times the second equation. So I'll copy the first one down and then multiply the second equation by negative 9. So negative 9x squared, negative 9y squared, and negative 81. Okay, and then I'll add them together. So then x squares are going to cancel. We're going to be left with 7y squared is equal to 63. Yeah, 63. And then divide both sides by 7. We're going to get y squared is equal to 9. And therefore y is equal to plus or minus 3. Ooh, nice answers. All right, so now that I have two values of y, I can plug them into one of the original equations and solve for x. So I'm going to choose the second equation, the nice circle. So x squared plus y squared is equal to 9. And inside I'm going to put positive 3. So that gives me x squared plus 9 is equal to 9. And therefore x squared is equal to 0. And therefore x is just equal to 0. And if I plug in negative 3, I also just get x is equal to 0. So this has two solutions, which are 0, 3, 0 for the x, 3 for the y, and 0, negative 3. So these two graphs only intersect at 2 points. All right.